Welcome to the Art of Healing podcast, the podcast that is dedicated to helping you connect with your mind, body, and spirit. This is Charlize, physician and Reiki master, and thank you so much for joining me. I would like to remind you that although I'm a physician, the information you receive in this podcast is for educational and entertainment purposes only. You can find my full disclaimer at my website, www.healingartshealthandwellness.com. If you like what you hear on this podcast, sign up for my weekly newsletter. Check your show notes for more information and for the link to sign up. Thank you. So today's episode is inspired from some input I got from a listener, and I hope she doesn't mind me calling her out or giving her a shout out. So I want to send a special thank you so much to Savannah Jack for being a listener. She sent me a wonderful message that was very inspiring. And she shared with me that one of the topics she was curious about was digestive health. So I thought, hey, what a wonderful chance to delve into a topic that I really had wanted to discuss as well, a topic that I spend a lot of my day on in the clinic. And also just to share with you listeners, if there are specific topics that you want to discuss with me that you want to hear more about, shoot me an email, send me a message, because it is so helpful. Although podcasts are a wonderful way to connect, they're a little one-sided. So I appreciate whenever I can hear from any of you, any input, any questions. So in your show notes, I'll put a way that we can stay in touch. And if there is a topic you want to hear about in medicine, if you want to talk about anything in energy medicine and Reiki, definitely send me a message. So what we're going to be doing during this podcast series is this first episode, we're going to talk about digestion basics. So we'll talk about the fundamental process of what it means to take in food, to digest food, and to eliminate the waste products. Then in the next episode, we're going to cover disorders of digestion or gut health. And we're going to do it in the way that we like to do in this community. We're going to approach it from an energy-based approach. So we'll cover it in the form of how dysfunction in each chakra can lead to digestive health. And then the last is we'll perform some exercises together to help us tune into our digestion. Throughout this series, I'll be reusing the terms gut health, digestive health, just interchangeably. So I just want to make sure that we all understand that, because you can use the terms either way. So let's talk about the basics of digestion. All living organisms require an energy source. Depending on the type of organism you are, that determines the type of energy source you require. So when we're thinking about digestion, it helps to go back to basic biology and some of what we would have learned in school. For us as mammals and as moving creatures, we require an energy source that is somewhat similar to us because we require raw energy, we require vitamins, we require minerals, we require other substances, trace elements. And in order to acquire those, the easiest way to do that is to ingest it or to eat it. That's in comparison to living organisms in the plant kingdom, because we're in the animal kingdom, and that's a big distinction. In the plant kingdom, plants require energy as well. They are moving, they're growing, they recover from injury, but they must require energy. And the way that plants acquire energy is through photosynthesis, by simply letting the sunlight land on their leaves, and a chemical process within their cells converts carbon dioxide to oxygen, and that's how they obtain energy. So as part of the animal kingdom, to keep us up and moving, and for instance, us talking, you listening, me breathing, we require energy from an external source, and the basics of doing that is eating. The human race has turned eating into much more than a biological process, which we're wired to do. So for us, eating is many things. It's a social activity, it's fuel acquisition, it's a way to bring us together. It's, in a darker sort of energy, it's a source of control. But the basics in biology is simply eating is required to get energy into our system to break chemical bonds, which makes energy available for our cells to run. So it's so easy to forget that because in our modern culture, food culture and food environment, it's become so much bigger and fancier. And there's so many different rituals associated with eating and emotions. It's become a huge deal, but the basics of eating is just to acquire energy blocks, to break chemical bonds, to make energy available for our cells. So let's start with the very beginning of eating, ingestion of food. When we are thinking about eating, the process really starts long before. So in the human body, the appetite is generated by a hunger signal. So we will begin to think about, is it time to eat, when that hunger signal starts to develop. So the hunger signal comes from a combination of the liver and the pancreas communicating with the stomach. And some of us may have a sense of a mood change. Some of us may have a sense of a growling or a tightening or discomfort in the upper abdomen, and that's from the stomach beginning to contract. For many of us, it might just be feeling tired or sleepy, but essentially a hunger signal is what stimulates us to want to eat. What further encourages that is if there is the appropriate stimulus that also encourages eating. So that's where the sight and the smell will come into play. If you smell food that's cooking or smells really good or spices, your nose has a nerve bundle, a nerve plexus that communicates directly with the brain. It actually has a pretty big and powerful connection with the central nervous system that starts a whole cascade of hormones that will help you produce saliva that gets your mouth lubricated in preparation of eating, and also will stimulate the production of stomach acid, or we call it gastric juices. And that's getting your stomach ready to accept food. And because we are creatures of ritual, and as a species, we've turned eating into a big process, the sight of the food as well can have a similar effect. Once the food is available and we're sitting down to eat, that chemical cascade that started in the brain and starts in the brain stem with the vagus nerve starting to communicate with the esophagus, the stomach, with the small and large intestines, is now encouraging the intake of food. So saliva production, there's actually some other things like the pupils dilate. And so this process is all preparing your body to take in food. When we walk through the digestive system in this slower pace, you start to understand that eating's actually a big deal. Our body has to get ready to take in food. And we'll get into this in the next episode, that when we rush our meals or we're rushed to eat, why it feels so badly, because the body is making a whole big preparation to start eating. So returning to when the food is there and you're about to take a bite, the mouth is the entry point of the digestive tract. That's where everything will start. So we have our teeth and our tongues, and our mouth has 2 or 3 main roles that it needs to do as far as digestion. The teeth and the tongue play a role in making the food smaller and easier to swallow and safer to swallow, because that food material is going to have to pass through the esophagus, but it needs to make its way over the respiratory tract. So the food must be made smaller, more liquid, just easier to get down that way. The tongue is how we taste, but the tongue is also a chemical sampler. I like to explain to my patients that once the tongue is tasting the food, sending signals to your brain, but then also to your body. So your brain will interpret the signals from the tongue as pleasant, unpleasant, sweet, sour, bitter, salty, savory. But the tongue is also telling the rest of your body what type of chemical is coming into your system. So particularly if the food you're eating is sweet, your tongue readily interprets and will send a sweet signal to your brain, which in some of us hits our reward center too much and can cause sweet cravings. But the sweet taste is actually from glucose or sugar. So your tongue is also going to communicate through a hormonal cascade indirectly with your pancreas. And it starts to tell your pancreas to start making digestive enzymes, lets your liver know to start making bile, producing to help with the digestion. Also telling the pancreas to start producing insulin. Insulin is going to start being made in the pancreas as soon as you start to eat or even before, because insulin's role in the digestive process is to get the free floating energy or glucose that will be in your bloodstream out of circulation and into the cells where it can be used for energy. Once the ingested material is moistened enough and soft enough that it can safely pass through the esophagus, we swallow. The signal for when to swallow is somewhat voluntary in that our conscious mind can initiate the action, and then also involuntary in that once we initiate the swallowing the material down the esophagus, it will progress without our control. So the food is chewed, then the is initiated, the respiratory tract has to be protected, so a covering goes over it, so the food material will pass over where air would normally enter, because if it does not, that food material will go into the lung, or what's called aspirated. And there, the food material will travel down the esophagus, where it's moved with a process called peristalsis. Peristalsis is a fancy way of saying muscle contractions that are coordinated. And the esophagus has to coordinate how fast the material will travel down into the stomach, as well as when the esophagus and the stomach can allow the food material to pass safely. As the food transits down the esophagus, there is a group of muscles that are nice and tight that are there to protect the lining of the esophagus, which is basically a transit and needs to move material and needs to stay well lubricated from the environment of the stomach, which is very different from the esophagus. So it's called a sphincter, and in the human body, there are actually several sphincters. So it's a group of muscles that stay contracted or nice and tight that will relax and open when it's time for that food material to pass into the stomach. When the esophagus is not bringing food material into the stomach, the esophageal sphincter is meant to stay closed so that acid from the stomach does not get into the esophagus. Now the process of digestion will continue with the stomach doing the job of chemically breaking down the food using hydrochloric acid, mechanically breaking down the food using those muscle contractions that we talked about, and processing the food for the next step, which is to enter the small intestines. Within the stomach, and I forgot to mention, even within the mouth and to a small extent the esophagus, the acquisition of energy that we've been talking about, trying to extract energy from the food, has already started, but the bulk of it hasn't happened yet. So even in the mouth, you can actually start to absorb sugars and some of the other smaller molecules from the food. But it's once that food enters the stomach that the big work of assimilation can begin. So the stomach accepts the food once it passes through the esophageal sphincter. The environment of the stomach is acidic. So you might remember from your chemistry classes, pH balance, which you hear the term used a lot, especially like in cosmetics. But in terms of digestion, what we want out of our pH. So a neutral pH is at 7. That's like what water is. So, it doesn't have an excess of ions, anions. It doesn't burn anything or hurt anything for us. A base is bleach. So bleach has a high pH, I believe around 9 or 10. And then we call acids anything that has a low pH. So acids like battery acids. And in our stomach, we actually have hydrochloric acid. The acid that's in our stomach is quite powerful. So the stomach itself is a very tough organ, very tough. It is designed to contain acid, hold it in place while it's constantly moving and churning. The volume of food that goes into the stomach will impact how well it can do this churning and the peristalsis. So all the time the stomach's churning, it's taking that food, it's making it smaller, it's mushing it up, it's turning it into a liquid material, and it's combining that powerful mechanical action with the acid, all of that to tear the food apart even further. The lining of the stomach can accept and absorb some vitamins, some nutrients, and it also has various chemical receptors. But the biggest job it's trying to do is make that food mushy, small, liquefy it so that it can go on to the next step, which is entering into the small intestines. Once the food is the correct consistency, that the absorption of nutrients, minerals, proteins, fat, calories can occur, it then enters the small intestines. And it is at the initial entrance of the small intestines, the stomach will release the material through another bundle of muscles, and it goes into the small intestines. And that bolus material will then blend with digestive enzymes produced by the pancreas. A lot of our discussion about the pancreas in modern times centers around insulin, which is important. And as we've been walking the digestive tract, the pancreas has been working on insulin production, which it actually makes a teeny bit all of the time. But it's now started to make boluses or surges because the pancreas got the chemical signal that eating has started and calories will need to be made available and must be pulled out of the circulation into the. The other role of the pancreas is to produce digestive enzymes. And we need those because although this food material is now nice and liquidy, it won't get into where we need it to, which is passing through the wall of the digestive tract, unless those chemical bonds are initially starting to break down. So it's in the pancreas that's going to produce and excrete into the small intestines these digestive enzymes, which will help break apart larger fat molecules, help break apart proteins to get down to the amino acid level to make them ready for absorption. And also this material will mix with the bile produced from the liver. So that all happens when that food material first enters the small intestines. After that initial mixing of bile and digestive enzymes for the pancreas, now the food will enter the long tract of the small intestines. So all through that very long tract and the several feet, centimeters of digestive tract, the small intestines now take over the job of assimilation primarily. So hopefully all of that food material is broken down small enough so that the small intestines can do their job of interacting with the food, extracting materials that we need from the food, and hopefully not taking on anything we don't want. And basically just that's the real part of digestion. Our understanding of the small intestines and the digestive tract has changed quite a bit over the decades. We've known that the small intestines and the large intestines have bacteria in them. The initial thinking in medicine was that it was like all kind of bad and needed to be controlled. But now we know that the bacteria that are in the small intestines are part of us and they help us, and we can't live without them, and that we must learn to befriend these bacteria. Some of the terms used in science are commensal bacteria, which is a sciencey way of saying our friends. But it's in the small intestines that this microbiome is another term you might hear, is that we interact the most with it and it interacts with us. So the microbiome, commensals, our good bacteria, our gut bacteria, are living in our small intestines. And what they're doing for us there is food material that's passing through the small intestines. A lot of it we actually can't digest, we can't use. But the bacteria that's lining our small intestines can. So that bacteria will take in that food material, will take in whatever it wants, help to break it down, and then will actually send us some of what we need in terms of calories, nutrients, minerals, vitamins. That's a very rough explanation, but it sends us some of what we need through the lining of the gut wall and then allows that material to pass on. So it's in the small intestines where our happy gut, good gut bacteria that we are learning that we want to befriend is actually doing the job of digestion for us. And we are just simply absorbing everything that we need from that food material and in a way providing housing, room and board for our gut bacteria. So for a place that they can live and thrive. Along the route, our immune system is playing a major role in digestion because, of course, we're taking in materials from the outside. The digestive tract is considered a closed system in physiology, meaning that when food enters the body, it's not passing directly into your system. Our digestive tract is taking it in, breaking it down. Anything that's chemical will go through the liver to be processed. And then all along the way, there's immune system components embedded within the wall of our digestive tract that are sampling, that are looking. There's parts of the immune system in the stomach that if certain triggers come in, the stomach is going to do an automatic reject. So that's to vomit. And as well in our small intestines, where the immune system is constantly interacting, sampling, making sure that the boundary stays nice and tight. The wall of the small intestines is meant to be tight. It is absorbing materials, and from the wall will actually make its way into our bloodstream, but not everything is meant to get through. So our small intestines is doing the assimilation, extracting the calories, extracting the amino acids, the proteins, all of the materials that we're going to go on to use as building blocks for our own tissues. On a microscopic level, in the digestive pattern, as we had talked about at the beginning of our talk, our cells are needing energy. So as living organisms in the animal kingdom, we're comprised of a multitude of cells. We've got neurons. We've got our skin cells. We've got these cells of our immune system, white blood cells. We have red blood cells that carry oxygen. We have muscles that help move our body. We've got cells that make up our bone. All of these cells have varying energy requirements, but the one thing they all have in common is they got to eat. They got to get some kind of food. So in our digestion, the whole reason we're doing that, and I revisit this with my patients frequently, is we're trying to feed our cells. Now, we as humans have turned food and meals into a fun time, but what our body really wants to do is get that energy out of that food into the cells. So as the small intestines have been working with your friends, your bacteria in your gut, your buddies, and extracting what's needed very gently, pushing along the things that we don't need. And the small intestines has varying neighborhoods, even has various places where the friends may congregate and live in clusters together. Those molecules that are going to be extracted make their way into the bloodstream, and depending on what they are, they may have to go to the liver for further processing to be made available. But once they do, then they'll get into the cells. So all of our cells have to have varying receptors depending on what's going in. But the primary target is glucose. So all of the different macronutrients that you take in are eventually broken down. And when I say break down, we mean to break apart the chemical bonds until we get to the basic unit of glucose. So we take in glucose in the form of sweets, and that glucose gets into the bloodstream. Then we also take in proteins, which get broken down to amino acids, and we will collect some of those into the cells. We take in fat. We love fat because fat has so many chemical bonds that we can break apart, get energy out of, turn eventually into glucose, or just store the fat. So that's why we like to eat fat. But all of those are getting broken down into a molecular level. So in your body, in those cells, those molecules that are needed for energy have to get into the cells. So insulin that we hear so much about, its role is to go to the cells, have a chemical conversation with the cells to open the cell up. The cells of your body are not open. They have to be made open, and insulin has to actually create some changes even in the DNA to open the cell up, make an opening for these molecules, primarily glucose, to enter into the cell. And from there, there's actually still more work that needs to be done, because that glucose, even though it tastes good and it's great, the glucose molecule now gets turned into energy. So in most of our cells, there are machinery called organelles that are going to take that glucose and break it down further and break down those glucose at the atomic level to release energy, primarily what's called ATP. And that's what we'll run all of our cells on. So returning back to the digestive tract, the small intestines will complete their work as far as assimilating, acquiring energy, and also even putting out things that we're not needing. And that material, which is now called chyme or chyle, I believe, now enters the large intestines. So it's in the large intestines where we actually continue digestion now in preparation for elimination, because throughout this process, we've taken out energy blocks and we've taken out the macronutrients that we need, but we also have to expel things that we can't use or no longer need. And that's what the large intestines will begin the work of. So the large intestines will focus primarily on reclaiming water, pulling water out of that material. And as that process happens, that liquidy material becomes more and more solid. The large intestines will also try to reclaim electrolytes that are precious to us that we need. Although we live in a world mostly of plenty, we evolved from our ancestors in times of harsh environments, heat, drought, desert. So our large intestines will devote quite a bit of resources to reclaiming potassium and chloride and other electrolytes, calcium, that our cells need to function. So in this reclamation process, that material that was liquid and loose now takes on a steadily more solid form, becoming fecal material. As the fecal material transits the large intestines or the colon, it will then enter the end, the terminus, the end of the process. So at the end, which is our anal canal or our rectums, this is the place where now our conscious brain can actually have voluntary control. So initially, when the digestion process started, we voluntarily controlled it as far as when we ate, what we ate, and when we swallowed. But then the digestive tract actually took over because it has its own type of nervous system that coordinates what happens, when it happens, how it happens. And the nervous system, or the gut brain, is in communication with the central nervous system, the brain, as well as the body. But it's been working fairly independently of the rest of the body, although it is influenced as far as how fast things will move, how fast digestion will move, how effective it is. But it's at the end of the large intestines that this fecal material now begins to collect. It's constantly collecting all of the time, but because we are living organisms that descended from, ancestors that often had to be very aware of safety, and now we have to be aware of safety, of timing, there must be some container or some way to hold that. So it's in the rectum that we have voluntary control, where the muscles are, for the most part, keeping a nice amount of tone so that as fecal material's collecting, it's not coming out. This is when things are working correctly. But when a certain volume is in that area and a certain amount of pressure hits, then we'll become aware of a need to evacuate, eliminate, or have a bowel movement or poop. In medicine, we always use fancy terms. And when that certain amount of material has collected, then we get a nice warning signal of, it's time to go, so that we can get into a situation, we can get to a restroom and eliminate this material. When the elimination starts, so that solid material has hopefully had everything reclaimed that we want, all of the water, all the electrolytes that are reclaimed from it. And now it is in the rectum and the anus that, when time allows, a process of relaxing that opening so this material can pass through, along with contracting the muscles in an appropriate way so that the material can be pushed through, and then hopefully safely so that it's coming out in a solid matter and it's not splashing in other places, which could cause infection, especially in women, in which the urinary tract is very close by. But it's in this expelling of feces, the poop comes out, and the digestive process is complete. Understanding the basics of digestion can give us a lot of insight into our lived experience as far as symptoms, our lived experience as far as diseases or diagnosis. What we just discussed is a place that I often will talk to my patients about, because discussing digestive symptoms can be the most difficult because the digestive process is so complex. We just reviewed how complex it is. And also, walking the digestive tract from the mouth all the way to the anus, we got a good understanding of how eating maybe is done a little too casually, because our body doesn't just eat and it's done. Whenever this process comes in, look at all of the organs that we activated. We activated our pancreas, we activated our liver, our gallbladder, we activated the adrenal glands to some extent. All of these organs had to be woken up. All of this had to be turned on to get the body ready, which is why the fasting state is so necessary, because this digestive process is not passive. Our digestive system burns calories in order for us to acquire calories. Next week, we will come back to the digestive tract, but we are going to review the digestive tract in terms of blocks in the chakra system and how that shows up in our tummies. We've done forms of this before for the endocrine system. We've done it for weight gain. I think we've done it for even chronic pain. That has been a long time ago. So in the show notes, I'll try to pull links to those episodes. If you are new to the show, it's been a long time since I've done these chakra blocks shows, and they're very interesting because it really gives us the insight into the mind-body connection. So we'll be doing that next week. In your show notes, you will see links to my website. You will see links to my weekly newsletter if you want to download a copy to listen to later. Particularly, this is a longer episode. I will be creating some handouts for this show in the next few shows. So you might want to sign up to get copies of those because it helps to have the visual. And once again, thank you so much to Savannah for this inspiration for these episodes. I really appreciate your feedback. Thank you for being a listener. Listeners, thank you so much. It's been great to be with you, and we will meet again next week and the week after that. And then we will actually be closing the season so that I can get ready for a few bigger projects, planning on returning in 2024. So as always, check your show notes. Thank you so much for being a listener. I appreciate it. If you like what you heard, leave me a review. If you have questions or you have ideas for other topics you'd like to cover in this way, send me an email, which you'll find in your show notes. Thank you so much. Bye-bye. Thank you so much for joining me for this episode of the Art of Healing podcast. Once again, this is Charlize. You can find out more about me at www.healingartshealthandwellness.com. Did you know I have a blog as well as online courses? Check your show notes to sign up for more information about healing arts, health, and wellness. Thank you. Please feel free to share this episode with your friends, family, and loved ones.